So how do we use then this to help us approximate values? So if I'm trying to find something, approximate a value at a function, but it's kind of a complex function, it's hard to substitute the value into that function and find something, especially when I don't have a calculator, then we're going to use linear approximation at a center value at x is equal to c. That is a place where it's easy to find the value of the function and it's easy to find the derivative of that function. So we're centering it at c, but I'm trying to approximate at a different value than CA, which is close to C, but not exactly at C. So we're going to find the tangent line at C, which is an easy value to find, or the center value, and then we're going to use that equation of the tangent line to substitute in A, which is where I want to approximate. And it has to be a value near the center. So you want to pick, like before in the exploration, we were picking values that 68 was close to 64, which was a perfect cube. So I used 64 to make the tangent line. All right. There are some clear steps. This is how you do it. Linearization approximation at x is equal to a. So we want to estimate or approximate at a. Find the equation of the tangent line at the center c of f of x in point slope form. Center is just a side note. Value. Oh, that's a terrible value. Value where it is easy to find derivative. So I should say to find, maybe I'll use proper notation, f prime of c and f of c. So we want to pick a value where that's easily done. And close by, they have to be close. If you're far away, it's kind of pointless. Okay, so we're putting that in point slope form. Here's the slope. Here is y minus y1, and then x minus x1, like that. That's point slope form. Then solve for y and rename it L. L of x. That's for linearization. That's a commonly used in calculus to indicate that I'm using linear approximation. So I'm making a tangent line and using that to approximate. Then substitute in a into the linear function and write the notation carefully. So we've come across this a lot of times before. The key is you need to find, you're approximating f of x at a, and I'm using L of x to do it, right? So you need that approximation symbol. A lot of people forget that part, and it's a shame you do all this work and you don't get any credit, okay? If you're asked to determine if it's an over or an underestimate, you have to see if it's curved down or curved up. So concave down or concave up. In the next chapter, we're going to discuss this, or in the next unit, how to determine using the second derivative. I wrote the rules in here now because this happens to be in the AP unit before unit 5, or unit 5. So a lot of times you are going to be asked if it's an over and underestimate anyways in connection with this. So the key is you're going to take the second derivative of the function at that value and see if you get a value that's negative or positive. If the second derivative is negative, and again, we'll do this in detail later why this happens, the function is concave down there, and it's going to be an overestimate because where a function is concave down, the tangent is going to be completely above the function except for the point of tangency. And if it's concave up, that's curved up like this, the tangent is going to be completely below the function at all of the points except at the point of tangency. So if I'm using the equation of a line to estimate a value, that value is going to be slightly below the actual value of the function. So you would have to take the second derivative and check. And I'm putting this in now, and I know we're going to refer back to this later, but I want all the notes to have it all together. All right. So the best way to do this is really to do some examples. So I'm asking you to estimate the square root of 3.9, determine if the linearization is an over or an underestimate, and then justify. And I realize I probably did not leave enough room, but we'll do the best we can here. So first of all, the function I'm going to use is f of x is equal to the square root of x. F prime of x is then going to be 1/2 x to the negative 1/2, or it might be a good idea to write it 1 over 2 square roots of x. Now I need to find a value, and I'm going to find a value to center this around. I'm going to center this at 4 because that's the closest perfect square to 3.9. So center at x is equal to 4. And the reason why we do that is because it's close, 3.9 is close to 4, and it's a perfect square, so it makes it easier. So we are going to do f of 4 is equal to 2. F prime of 4 is equal to 1 over 2 square roots of 4, which is 1/4. So now I can write the equation, which is y minus 2 is equal to 1/4 x minus 4, and then solve for y, or f of x, because we're using f of x here. You could also write either way, that would be fine. But f of x here. So I'm going to solve for and use L of x instead, because it's indicating that that's a linear approximation. So you know what? I actually think I prefer having a y there. So that's going to give me 1/4. Do not distribute. Do not do that. Just leave it. Plus 2, like that. Essentially, I'm trying to find f of 3.9, and I'm going to use this L of 3.9 to do it. So that's going to be 1/4, 3.9 minus 4 plus 2, which is 1/4 times negative 0.1 plus 2. 1/4 of negative 0.1 is going to be negative 0.025 plus 2, which is then going to equal 1.975 when I add without a calculator, right? So this is all trying without a calculator. So that's my approximation. So I'm approximating that the square root of 3.9 is approximately 1.975. And then, is it an over and underestimate? Well, if I'm checking if it's an over and underestimate, first of all, I know that the square root function looks like this. So it's concave down everywhere. So in our case here, the approximation must be an over estimate, since the function f of x is equal to the square root of x is concave down at x is equal to 4. Now, you could also say concave down everywhere. Later on, if you were going to do it properly, you would have to find the second derivative. So f double prime of x is equal to, and then I'm going to use negative 1/4 x to the negative 3/2, which is negative 1 over 4 square root of, square root of x to the 3rd. You have to find that at the number 4. So that's going to give me negative 1 over 4 times the square root of 4 to the third, which is greater than or less than 0. So less than 0. You don't even have to finish it. I know that it's going to be 8 times 4 in the denominator, so negative 1 over 32. But the key is this is less than 0. So since f double prime of x, f double prime at 4 is less than 0, the function f of x is concave down at x is equal to 4. Therefore, the approximation is an underestimate. Ooh. All right, now I want you to try the other one. It's very similar. Now, the function for that one is f of x is equal to x to the 5th power. So try that now on your own.